So today we're going to be doing array2 big difference. Given an array length 1 or more of integers, we want to return the difference between the largest and the smallest value in the array. And this is just a side note that says, okay, there's this function which if you put in two numbers, it'll calculate the highest, or sorry, the lowest, because this is math.min, and this is math.max, which will calculate the highest. So in my so there's really just going to be three solutions to this, and I'd like to cover each one. And essentially, the first solution will be a solution, and then the next solution that follows will be sort of a more efficient way of handling the problem. And then, of course, the next solution that follows after that will be far more efficient than the last. And so as we explore more solutions, we're going to sort of optimize our code and sort of make it more efficient and more clean and more condensed. So the first thing that comes to mind when it says return the difference between the largest and the smallest value in the array, well, I actually need the largest and the smallest values in the array before I can calculate the difference. So what I'll do here is I'll have int min is equal to 0 and int max is also equal to 0. So the minimum and the maximum value. So I'm going to default those to 0, and somewhere on in my code, those values will eventually update. This will be the code here, and then after it's all said and done, I can just return the minimum minus the maximum, okay, or return the difference, and the difference will essentially store the minimum minus the maximum. And so there's this. So what I think first is, okay, I need to iterate through the array to judge each value, whether or not it is the maximum or the minimum. And there's this famous way of actually attaining the minimum value in the array, and there's this famous way of attaining the maximum value in the array. So the way is that, okay, we assume, so let's say we're trying to get the maximum, right? Now we assume that the max value in the array is in fact the first element in the array, which is referenced by the 0th index, hence nums of I. And so we say, okay, if at all, while we're in this for loop, while we're looking at elements, if at all, nums of I, which is of course any given element on any given iteration, is less or is greater than the highest value that we had set for ourselves, which is of course the first element in the array, then change the highest value to be that element on that given iteration. So this is a way to sort of vet through the array and get the highest value. So nums of I, if nums of I is greater than the highest value, which is of course we're assuming to be the first element in the array, then the highest value will just be set to that element. And the highest value will now store this new element. And then when we come again, we then compare nums of I again, which is of course now a different element. And we say, okay, is that greater than the highest value that we have? Which was of course the last element which came before it. And so it continues sort of moving through this pattern, and it continues updating the highest value if at all a higher value exists than the one that we previously set. And so since we're assuming that the maximum value in the array is the first element, we actually have to start our assessment from the first element. That is, of course, we could get away with doing this, but we start our count from the first element because we're assuming that this is the highest value. So we want to compare it to the next element in the array. And so since I takes care of the index, we're actually looking at the second element referenced by the first index, which is of course not actually the first index, but it has the number 1. It's actually the second element. It's referencing the second element. So that's how we get the maximum value. And if we want the minimum value, what I supposed was we'd follow something of the same type of, we would follow the same approach. And you'll see that this one here, so with the minimum, we'll assume, again, that nums of 0, which is of course the first element in the array referenced by the 0th index, will assume that that's the minimum value in the array. And if at all nums of I, if nums of I is essentially, well, we're going to start our count at 1, right? So if nums of I is less than the lowest value that we had conceived of, then the lowest value will now be set to nums of I. And so that gets us the lowest value as well as the highest value. And additionally, we could have something called int difference, set that to 0. And difference will essentially equal the highest value minus the lowest value, because we want the difference between the highest and the lowest. We don't have to worry about the negatives because, of course, we don't have to worry about a negative answer because, of course, a high value minus a low value will always reap a positive answer. And then, of course, after we're done with that, we'll just return the difference. Yeah, oops, must have, yeah, you know, I must have used different variable names. If I were to change this to highest value, or actually this would be lowest value. So then we get all greens. Now, a couple thoughts. The first thought that I'm having is that we actually don't need to, could we, so whenever you use 2 for loops, always ask yourself if you can merge it into one. And in this case, we can merge this functionality into this for loop so that it can vet between what is the highest and the lowest value at the same time. So we can just take care of this, and we can say, okay, this will be, so it's going to actually do both at once and update the values. And then you'll see that when we return the difference between both of them, we still get all greens. Now, another thought is, can we somehow reduce this code here and make it less, make it a little more efficient? And instead of storing difference, storing highest value minus lowest value in difference and then returning it, we can just return the highest value minus lowest value. And then you'll see we get all greens again. So you can see that we don't need this either. So we're progressively just increasing our efficiency throughout the code. Something else you could ask yourself is there a completely different way to do it? Well, this suggests that there is. So what we would do here is, let's go ahead and take care of this. And we'll say, okay, the lowest value will now equal math.min. And then this will be, we're going to say that this is the lowest value, and then we're going to compare it with nums of I. And the highest value will now equal math.max, and this will be the highest value, what the highest value was before, and then nums of I. And you'll see that we still get all green. So you can see that we're just really, really trying to reduce our code here, and it's working. Now, what this does essentially, let me try to make it more clear by using the lowest value as an example. We have two things. We have nums of I, that equals something, and then of course the lowest value equals something as well. So we start our count at 1. We're assuming that the lowest value in the array is the first element. So we start our count at 1. And we say, okay, what is, so the lowest value then becomes the lowest between the lowest, what the lowest value is initialized to. So the lowest value in the first iteration is initialized to nums of 0. So that would be, of course, the first element in the array. let's just take this for example, right? 2, 10, 7, 2. So the lowest value in the array, or the first element in the array is 2. So that we're just assuming that's the lowest value, and we're at nums of 0. Now what we do is we start our iteration from nums of I, which is of course the next element in the array, and we say, okay, the lowest value which stored 2, we're now looking at nums sub 1, and that is equal to 10. And so this method essentially calculates the highest and the lowest value between both of these. And you'll see now that it updates what the lowest value is. So since the lowest value between both of these numbers is 2, the lowest value is 2, and then I gets incremented as we come back to the for loop in this area, and we're now looking at the second element, so 0, 1, 2. We're looking at the third element referenced by the second index, which is 7. And so the lowest value is this, and we're looking at nums of 2, so we're now looking at 7. And then it calculates the lowest between both of these. And then of course we're left with 2, and so now we're looking at nums of 3, so we're looking at the third index, 0, 1, 2, 3, referenced by the third index. We're looking at the fourth element. This is the fourth element is 2, and so the minimum between both of these would just be 2, and so 2 is essentially the lowest value that we get. And then the highest value, obviously going through that, would be 10. 10 minus 2 is 8, and so we return 8. So now we're missing something, it seems, or the lack thereof. But so that's how we do that.